Hello everyone. So in this video, I'm going to do a quick overview of Git, right? So Git is basically what we call a version control system, and a version control system, or VCS, is also sometimes known as a source code management or revision control system. And the primary purpose is to track and manage changes to source code in a software project. It's a very important component in a modern DevOps workflow. So if you haven't seen my video or lecture on DevOps, please watch that first. And because it helps to accelerate code development in a software project team. Okay, what are the key features of VCS? Okay, the primary one is the ability to save the content or state of a code base. So the content here refers to the content of the source code files as well as any other configuration files that constitute a complete code base. So as developers work on the code base over time, they are going to make changes such as creating new files, modifying and deleting existing files. After a series of such changes, they are going to reach a point which can be considered as a milestone towards the completion of the application. Okay, so at this point, at this milestone, they're going to tell the VCS to save the content of the code base. Okay, so this save content is called a snapshot, and multiple snapshots will be created as the code base is gradually built upon and evolve towards its final complete state. Okay, so the snapshots represent different versions or revisions of the code base, and they will be annotated with metadata such as the author, the date, and the messages relevant to the snapshot. Okay, so let's take a look here. All right, so this is a simple example here. Let's say you have a web application project which initially starts off with a single file, index.html. You're storing this as a snapshot in the VCS, and this was the time when the snapshot was made. Okay, and then perhaps about 2 days later, the developer creates a further modification, makes a further modification to this index.html, okay, and then also adds a headline to the index page, okay, and that will be a snapshot that is created, okay, and then you have another change on the 10th of September, let's say, and this is going to be adding in a new HTML file, a new PNG file. Again, a snapshot is made, and then the final change on this date here is going to be making changes to the newly added HTML file, again, after which you make a snapshot. So basically, we are creating snapshots after every set of changes, okay? But you don't necessarily have to be after every single change. You will typically create a snapshot after a series of changes that has evolved the source code files to a state which can be considered a milestone. Okay, so what is a milestone? Of course, it's very subjective. It depends on the development team. Okay, so related to the capability to capture the revision history of a software project, the VCS also provides support to uniquely identify each snapshot and to compare two different snapshot versions in the history timeline. And most importantly, we can revert the code base back to older versions if an error occurs in the latest version. And this is usually when we want to identify the point at which a bug is introduced into our source code. This is a very common situation. You write code, you save a bunch of snapshots, and then at a certain point in the development workflow, you suddenly realize, oh crap, there is now some bug in the latest version of my code, and I want to go back to a previous version of my code where the bug did not exist. Okay, so this is very common, and that is a very important feature of VCS, which is to go all the way back in time to an older snapshot. Okay, so to do that, the VCS has to maintain a complete revision history of the code base from the start, okay, until the end of its lifetime, so that the developers can perform root cause analysis to identify sources of bugs. Okay, the second important feature of VCS is to support code development in parallel. So in a real life software project, you're going to have a team of developers that are going to collaborate together to work on the same code base at the same time. So every developer is going to be assigned to work on a feature to implement in the code base, or maybe to fix an existing bug in the code base. So all of this work is going to be going on at the same time. So the VCS has to make sure that all of this work from these developers are isolated and independent of each other. And then when the work has been completed, they are integrated or they are merged back into the main code base. And at this point, when you have many different people working independently of each other, they may end up modifying the same source code files, which means there may be a conflict, and so the VCS will make sure that any conflicts are resolved appropriately. Okay. The other useful feature of VCS is it's going to integrate with other project management tools. So if you have bug tracking tools to keep track of bugs in your software, or your project scheduling software, your VCS is going to integrate with all those other things as well, and this helps to speed up code development and keep your project on schedule. Now, the most common form of VCS is a distributed VCS, where the entire code base is actually mirrored on multiple machines. So you don't actually have a main server, you have more of like a P2P architecture, where the code base is going to be available on multiple machines, where one of the machines will function as the central repository server, and then the developers will download the complete copy of the main code base from there. Okay, this is known as cloning, and this copy will also include the entire revision history of the code base. Then the developers will work in parallel in their local clone. So here you're going to clone, alright, going to clone everything down to your local repository, and then you're going to keep working on your local clone. You modify your source code files and so on. Of course, you can modify the same source code files now because you are working from a local clone. And then once you have completed whatever changes you have done, you're going to push all these changes back to the main copy or the main repository server. Okay, then you push it back to the main repository server. So that's essentially how it works. Okay. Now, the most widely used version control system is basically Git. This was an open source project that was started in 2005 as part of the ongoing work on the Linux operating system by Linus Torvalds. Git is supported in all the major IDEs, so most or nearly all the major IDEs have a plugin that allows you to kind of work with Git directly. And there are also like just separate standalone Git clients, GUI clients for Git that allows you to just directly work with the major public code hosting services. Okay, so right now the three major public cloud services that allow you to host a Git repository are GitHub, GitLab, and Bitbucket. All these three companies or these three organizations, they have public versions of their services which are available for free, and they also have private versions which offer additional functionality for enterprise usage. Okay, so for private usage, for enterprise usage, they have additional facilities, but you will have to pay for that. So that's basically Git. Now, earlier I just mentioned that one of the key features in Git is to allow code development in parallel, right? So you are going to have multiple team members in a software project team working on different features of the code base in parallel at the same time. Okay, so how is that done? It's done through something called a branch. Okay, so in Git you have one specific branch called the main or master branch. Now the main or master branch basically holds commits or snapshots that represent code base that you are going to deploy on your production server. So it represents, okay, so all these green circles here, okay, these green circles are commits, and they are green means they're on the master branch. So any green circle is a commit on the master branch. It means that the code that you save here in this commit, these circles are commits or snapshots. So the code that you save in these commit or snapshots, they represent a complete working application that it can already be deployed either on the production server or on the staging server for testing purposes. Okay, and then any additional new work that is started by the team members in the project team will be done in a branch. Okay, we call this a feature branch that starts off from the master branch. So let's say you're a team member of a project team, and you're assigned to work on a feature. Okay, so what you do is you're going to start what is called a feature branch, and you're going to make commits into your feature branch. Okay, and your branch will start off from one of the commits in the master branch. Okay, so you keep making commits into your feature branch until your feature branch is complete, which means whatever you're assigned to work on, you have completed it, then you're going to merge or you're going to integrate, okay, your feature branch back into the master branch, okay. And then that's the same thing that the other team members in your team will do as well. They also start their own feature branches and they will create commits on it, and then you will merge it back into the master branch. All right. So the master branch is typically going to be on the central repository. So in central repository, you're going to have a master branch, and then you're going to pull the master branch, you're going to clone the master branch to your local repository. In your local repository, you're going to start off your own feature branches, which you are going to use to implement your own work. And then when you're done, you then merge it back to your local master, and then from your local master, you can push it back to merge with the remote master branch in the central repository. Okay, so that's kind of the general workflow with branches. Okay, so when the work is complete, sometimes when you're merging these changes back, you will have a conflict. Okay, so like for example, like right now I've merged, say like I'm working on some feature, I've changed some source code files, I've merged it back into this commit, and this commit now is in the master branch. Someone else is also working on something from the master code base, make some changes, and then now this person tries to merge it back, and at this point there can be a conflict because this person might have been working on some source code files, the same source code files that I was working on. So when you attempt to merge back from your feature branch to the master branch, you can have a conflict. Okay, so if there is a conflict, then generally what happens is the developers who are responsible for the feature branch that causes the conflict, they're going to sit down, they're going to have a discussion, and they are going to resolve the conflict. Okay, so conflict resolution is an important process of working with feature branches in Git. Right, so that's how you work with branches. Okay, so here's another example here. So again, here you have a long running branch, the main branch, master branch, and then you have various feature branches. So you have a feature branch here, you have another feature branch here, and you have a bug fix branch here. Okay, so another example of using branches. So for a very large project, you may not just only have one feature branch, you may actually have a variety of branches other than the main master branch. Okay, so you're always going to have the main master branch, and the main master branch, the idea is that the code base or the commits in the master branch are basically going to be a code base that is complete, that is functional, that is tested, that is working, that is ready to be deployed on the production server. And then of course from the main master branch, you can start off a whole bunch of branches, and you can have like, you know, secondary branches, tertiary branches, you know, second level, third level, fourth level, and then all these branches can merge back into each other and so on. So it's a very complex branching workflow, right? So you can have a very complex branching workflow. Now this kind of workflow is okay, but not so good for a CI/CD pipeline. Okay, so when we work with the CI/CD pipeline, if you have forgotten what a CI/CD pipeline is, please revise my lecture on DevOps. Okay, but when you're working with a CI/CD pipeline, you're going to use something called a trunk-based development. Okay, so this is how you will use Git or any other VCS of your choice when you are working with a DevOps CI/CD pipeline. So what is trunk-based development? In trunk-based development, you are not going to have so many branches like this. You're not going to have release, develop, multiple feature branches, hotfix. You're not going to have like 6-7 feature branches all going on at the same time. Okay, the reason is because when you have many feature branches, okay, when you have many feature branches, at some point when you merge them back into the master branch, the chances of a conflict is very high. Okay, when you have a conflict, you have to resolve the conflict, and this means that multiple developers need to get involved. And when you have a conflict that involves code that has been worked on by many different developers, that discussion can be very long, can be very intense, can be very heated discussion, and that can take a long time to resolve, which is not good, which is not kind of so good for CI/CD pipeline. Because remember, DevOps and CI/CD pipelines, the whole idea is to push your code out as quickly as possible for your customers, or for your end users to use. So you don't want to have too much time where people are arguing about how to resolve conflicts. So the idea of trunk-based development is to minimize the amount of conflict resolution you need to do. And the way we do that is to make the branches very short. So if you have branches, okay, the branches are very short, you only have a few commits on a branch and you merge them back into the master branch very quickly. So this might be an example, right? You have a feature branch, you just make 2 commits to feature branch and then you merge it back to the master. So you're not going to have a feature branch that have 500 commits, then only you merge back into the master. Okay, that's not good. You just have a feature branch, 2 commits. So very short feature branch, you merge it back into commit. Or you might even just merge directly. You might just merge directly from your local master directly back into the main master. Okay, so now the main master, we call this the trunk. Okay, so we merge back directly to the trunk. Okay, so we try not to have multiple lengthy isolated branches. Okay, and the main purpose is, of course, you want to make sure that the master branch code base is always ready to be deployed. It's always ready to be deployed. That's the key point of trunk-based development. So here is how trunk-based development looks like. Okay, so if you have any branches, you make sure your branches are short-lived. Short-lived means you only have a few commits in them before you merge them back into the master or the trunk branch. Okay, now how short-lived it is, that's up to you to decide. So it can be just 1 or 2 commits, maybe 3 or 4 commits, but most certainly you're not going to have 100 commits in your branch. That's not good. Okay. So this was a diagram or a slide from the DevOps workflow. So the basic idea, of course, is that every time you push to your remote repository, you are going to want to automate the build process and the test as well. So every time you push, you create a new branch, you push your code changes to your new branch on the remote repository. Your DevOps workflow should use appropriate tools to trigger a build. So you immediately compile the latest code changes you have pushed to your branch, and then it will immediately run a bunch of unit tests on that code as well. Okay, so this is where the CI aspect of a DevOps workflow comes into play, right? So if you don't have CI, then when you push your code, all that happens is your code just gets pushed up the remote repository and that's it. Nothing else happens, right? So with CI, when you push your code, at the same time, the code that you push up to the remote repository will immediately be compiled. There will be a build process, and then the compiled code will be tested by a bunch of unit tests. And if there's any problem during the build process or during the testing, there will be a notification that will be sent either to the developer or to the project manager. So straight away, we will know that something is wrong. Okay, so that is the very important quality aspect of CI in a CI/CD pipeline. All right. Okay, so this is just a very short overview of Git. Obviously, to work with Git in detail, really there's a lot more you need to know. There's also a very complex explanation of Git architecture, which I have excluded here. If you're interested to learn more about Git, there's a separate workshop for Git.